Solana developers released a really cool new feature, which is called GitHub Workflows. And what it allows you to do is now you don't need to build and deploy your programs locally anymore, like with lots of commands. But what you can do instead, you can just use a GitHub action, which builds and deploys your program. It also automatically uploads your IDL, if there is one. And you can also verify your source code using Solana Verify. Completely automatically. And it also supports a multisig squads integration. So if you enable the squads integration, it will just create you a transaction which sets all the buffers and you can approve it in squads. So what we're gonna do today is we're gonna build an anchor program. It also works for native programs, but we're gonna build an anchor program and then we're gonna build a GitHub workflow which completely automatically runs the tests, builds and deploys the program, and in the end we're also gonna build a squads integration. So for that we're gonna start here in the Solana developers GitHub workflows repository. And here you can see lots of documentation. And yeah, this is all the things it supports: IDL, squads, program deploys. It also has caching enabled, so it's like makes your builds faster every subsequent build. And yeah, this is how easy it is to use it. So basically it's just one line of code. You just reuse the workflow from this repository. It's also tagged to a version, so we're gonna use version 0.2. Maybe by now there's a newer version. And then we just need to set a few things here. So we need to set our program ID. Actually, this one is also taken from your anchor toml if you don't define it. But for now, we're just gonna use this, and then we can define our network. So that supports devnet and mainnet. Then here we can say if it should deploy the program or not, if we want to upload our IDL. Currently, it's only supported for Anchor IDLs, but soon, hopefully, Kodama IDLs as well. Then if you want to verify the source code, and then if you want to use squads integration. So the first thing we're gonna do is exactly this. So we're gonna run the tests and we're gonna build and deploy to testnet. So for that I created a completely new repository here. It's called Workflow Tutorial. And I added a few GitHub secrets already because I don't want to show these on screen. So for that we're gonna go here to secrets and actions. And here we can see our secrets that this repository will have access to. And the first one is our devnet deployer key pair and the mainnet deployer key pair. So for that I just used the local key pair that I had anyway on my machine, and I filled it up with devnet sol and sol for mainnet. And then we have the Solana deploy URL and the mainnet Solana deploy URL. So these are just RPC URLs. I used QuickNote, but you can also use Helios or Triton or whatever is your favorite RPC provider. For mainnet, I would definitely recommend you to use a paid one because otherwise the program deploys are super slow and might fail. And when you have these four key pairs set up, or these four secrets, then we can start. So now I'm gonna open this workflow tutorial in Cursor. I recommend Cursor, it's really nice. You have some AI stuff here, but you can also use Visual Studio Code. And now we're just gonna create ourselves an anchor program. So just anchor init, and we gonna call it workflow -tutorial. Operation not permitted. So let me reopen this. So gonna open a new window and I'm gonna open my workflow tutorial again. And I'm gonna open the terminal, and now we're gonna do anchor init workflow -tutorial. So now it's creating us an anchor program. And for these GitHub workflows to work, actually the program needs to be in the root at the moment. Maybe later in the version we can also do it so that you can set a work path or something. But for now the program always needs to be in the root. So I'm just gonna move it out of this folder and delete this folder here. So now we just have an anchor program in here. So we can do anchor build and we can run anchor test. So this should hopefully work out of the box. So this is now building the program. And yeah, now what we also want to do is I want to show you how you can deploy your program under a cool vanity address, because why not, right? So what we're gonna do here is, while this is building, Solana -keygen grind starts with, and we're gonna start it with WO for workflow. So now we have this key pair here, vocur, and we're gonna use this key pair to deploy. So let's see if our build was already done. No, not quite yet. So what we want to do is we set this key pair here as our program key pair. So I'm just gonna go here to target, deploy, and I'm gonna copy this in here. I'm gonna delete the key pair we had before, and just copy the name. You don't really have to do this. I'm just wanna show you how you can do a nice vanity address as well. So now I have set this key pair in here, and now we need to also update our program ID to this program ID, and we need to update it in the anchor toml. So now our program will be deployed under this address, and this here we also need now to add as an environment variable in our GitHub action, because the GitHub action also needs to know about this. So for that, we're gonna go back here to our workflow, and we're gonna see, okay, we need the secret program address key pair. So now we go to our secrets here, and we're also gonna add this one. So program address key pair, and I'm gonna copy this over, and we add the secret. This is mainly so that our workflow knows where to deploy this program. You can also just use the key pair that was here generated for you under target deploy, but we want to have a nice key pair that we can recognize throughout the tutorial. So that's why we called it vocur. Okay, so our build was successful. Let's see if we can also do anchor test. And so this should work. And now we're gonna create our workflow file. So for that, we create a new folder here. We call it .github. And this is just a convention. And then we add a new folder here, which is called workflows. So, and in this workflow folder, we now create our GitHub workflow. So I create a new file, and I'm gonna call it devnet build.yaml. And now we're just gonna copy the workflow from this workflow repository here. So I just gonna copy this, put this in here. And here you can see it's now using the reusable build at version 0.2.0, and it uses the program name Hello World. So for us, this will be workflow tutorial, I think underscore tutorial. Then devnet, we want to deploy, we want to upload the IDL, we don't want to verify, and we don't want to use squads yet, because that only works on mainnet. And now we are already good to go for building and deploying. But what I want to add as well, I just also want to add a test.yaml. And for that, I'm gonna just copy here this test example. And this will now run our tests. So for that, we're also gonna call it workflow underscore tutorial. And it's using the workflow test YAML here. Also a reusable workflow. And it will run these tests whenever someone pushes to the branch main and any of these things here change. So basically it runs in only if you change the tests or the program. And it, the program to test. So and now we're gonna commit this. So for that, we're gonna, not sure why it's not showing this here. We called workflow tutorial. So here we can see now I just gonna push this. So it's just the program, the workflow tutorial, our key pair. You probably wouldn't want to commit this, but it's not super dangerous because it's only used to create the program address once. Afterwards, you can't really do anything with that key pair. So we're gonna call this initial commit, and we're gonna commit this. And now here in our repository, the magic happens already. So we have now, if we click on actions, we have here anchor test. So this is running automatically already because we pushed something to main. And then we have here devnet build and deploy. And now I can just run this workflow. And now this workflow will build the program, deploy it to devnet, and upload the IDL. So it's really as easy as that. And yeah, for that it's using the key pair that we defined in the secrets. So now this will, of course, take a while. The first run actually also runs a little bit longer than the subsequent ones because there's caching. So it caches the Solana install, the Anchor install, all the cargo files and the node packages. So the second one will be much faster. So now we're just gonna let this run here. Maybe we have a look at this build and we're just gonna speed this up.
A few moments later.
So that was successful. So it takes a while, but every build after the first one will be much faster. So this time now it took 20 minutes, but the next one will be much faster because it's caching the Solana install. And most of the time actually goes for the Anchor builds because it for somehow compiles everything multiple times. Maybe that fixes itself with the next Anchor version. But now we can see our build was successful. So let's have a look at this program on devnet actually. So I'm gonna copy this program ID, gonna put it into the Solana Explorer for devnet. And now we can see the program was deployed completely automatically. And also the Anchor IDL is uploaded. So everything is here now. So that's really nice. And another thing, the tests are also green. So we can see that that also took a while the first time. So you're just gonna restart it after a bit, and then we can see that the next one is much faster. But you can see it was, it sets everything up. So it installs everything like you would do locally on your machine. Anchor, Solana, Node, whatever, cargo. And here we can see run tests was successful. And it ran the tests. So here it's also compiling everything again. But you can see it was successful. And here we have the signature. Okay, cool. So we are already done with devnet. Now we want to do mainnet. And we also want to verify our program. So we're gonna go back to this workflows here. And this time we're gonna copy the mainnet workflow. So here we're gonna just create a new file, and we're gonna call it mainnet.yaml, and we paste this one in here, and we're gonna call this workflow tutorial again. And this time we are basically calling the same workflow, but this time we also want to set verify to true, and squats we don't want to do yet. So for now we just want to deploy the program to mainnet and verify it. And then we're gonna transfer the authority to a squats, and then we set squats to true. So what I'm gonna do now, I'm just gonna push this. Now network is mainnet, workflow tutorial is our program name, and priority fees we will get from the workflow itself when we trigger it. And we have the program address key pair, just the same one as for devnet. You can also define another one if you want to. Then we have the mainnet deployer key pair. For me, this is the same one. And then we have the mainnet Solana deploy URL. So it's just the mainnet RPC URL. So I'm gonna push this, and then we're gonna start this build. And this one will hopefully be a little bit faster. And it will also deploy our program to mainnet now and verify it. Verifying basically means that it takes the program and it builds it into a Docker container, and then it compares the hash of the build that was built from the Docker container with the hash that the on-chain SO file has. You don't need to care anymore how this works, but it's actually quite cool. So it writes a PDA on-chain where you have the commit hash and the URL and the program name, and then it calls the OtterSec API, and the OtterSec API also triggers a build, and then it compares the hash with the on-chain hash. And since we then have a third party that also verified it, then we can be sure that it's verified. And everyone can also run the verify command itself themselves. I'm gonna show you this later. But now let's wait for this release to mainnet to run through, and then we're gonna transfer our authority of our program to the squats, and then we're gonna set squats to true, and then we're gonna build again. So let's look at this.
A few minutes later.
So that was almost successful. If we now go to mainnet, we can see everything here is green. And we have the IDL uploaded and the program, but the verification step failed sadly because it couldn't find the deploy slot, so it's quickly gonna restart this. And also whenever you do stuff on mainnet, it makes sense to look at the priority fees that are currently needed and then set them accordingly, so then it will be a little bit faster. So I'm gonna not rerun, just gonna rerun this once, and then we're gonna see that the verification also works. I think we need to make the Solana verify a bit more robust, that if it like can't find the deploy slot, that it still is able to verify. But yeah, I'm just gonna quickly rerun this, and hopefully this time the verification will also work properly. And then we're gonna transfer the program to the squad's multisig. So let's just quickly wait until the build is through again.
A few inches later.
So this time it fails because I didn't have enough mainnet sol. So I'm quickly gonna close my buffers. So you can do Solana program show buffers, and then you can use Solana program close minus buffers. And this will close all your buffers, and then you hopefully have enough sol again. So let's see, Solana balance. So now I have 2.6, that should be enough. So I'm gonna restart this again. And we gotta just watch it.
Tomorrow.
So now this finally was also successful. So we need to get this thing fixed in Solana Verify, but on the second time it worked, and now I also had enough sol. So you can see there's a few things different now. So here when we write the IDL, wait, what did I wanted to show you? The program upgrade, then it does the IDL upload, and then it does here this verify build. So what it does here, it builds the program in a Docker container, and then it sends it off to the OtterSec API to actually verify that the build is exactly what the source code says it was. And here you can see it's comparing the on-chain hash with the executable hash that OtterSec built himself. And now if we refresh here in the Solana Explorer, hopefully, we will also see that the source code is now verified. And this is of course very cool, because now here in the verified build tab, you can see all the information about the build, and everyone can actually be 100% sure that the source code here was actually built from the source code that it says it was. So it's really cool, and it comes with this GitHub workflow basically for free. So you don't need to configure anything else. So this, yeah, it's just one boolean that you need to set, verify my program. So this is super cool. And now what we want to do, now we want to transfer this program to a multisig to make it even more secure to deploy it. So this is like highly recommended actually. And for that here we need to add our program in the squads UI. So I think I did this already here. So you just do add program, and then you add your program address. And now we need to set the authority of our program to the multisig. And for that we just set this, press this button, set authority, and then we just copy this command here, Solana program set authority, and I'm just gonna put it in here. This will finalize, and now our program cannot be upgraded by our local key pair anymore, but only by the multisig. So make sure that's actually what you want. So now I say verify authority, and now we can see that the authority is now the multisig. And now I want to automatically use squads to deploy my program. And for that I need to set two new environment variables. As you can see here, I now need the mainnet multisig and the mainnet multisig vault. So I go to my program. Here I go to the settings. I scroll up. I go to the settings, and here in my secrets, I now add two new secrets. So I need to add the multisig, mainnet multisig, which you can find here in the squads UI under settings. And here you need to confirm that you really want to show this, because you don't want to accidentally transfer your authority to this one. So you just copy it and you put it in here. So this is your multisig address. And now what we also want, we want to add the multisig vault. And the multisig vault you find here on the left side. So that one is actually the one that is the authority of your program. So that one we now add here. So I copy this and I call it mainnet multisig vault. So I add this as a secret. You could theoretically also not add it as a secret, but maybe you don't want to show everyone your multisig or whatever. But yeah, so now that we have this, set this as well, all we need to do in our workflow now, we go here to mainnet and now we say use squads, we set also to true. And now we can push this. And now if we rerun this workflow, it will actually create us a transaction in our multisig. So we go here to actions and we go to our mainnet release and we trigger it again. And once this is done, so we're gonna look at it again in a time loop, time speed up. And once this is done, we will get a transaction in squads that we can then approve, and then we can have like multiple people in our multisig, for example. So for now, I'm just a one-on-one, but you could have, if you have a team of 4 or 5, you could, for example, say 2 people need to approve this transaction to be really sure that we really want to do this upgrade. This is it's a great security feature, and I think, yeah, it's definitely recommended to use a multisig and especially squads. So now let's look at this, and once this is done, we're gonna approve the transaction in our multisig. Be right back.
Day 2.
So that was also successful. So now we have released to mainnet, IDL, and verify using squads. So the whole step completed. And as you can see now, what it does after we did the with squads true, it created us a transaction here in our squads UI. And you can see it's low risk. And we can also simulate it, and simulation was successful. And I can look at the details here. And this transaction has 3 instructions. So the first one is the verify PDA. So it writes data on chain so that we will be able to verify our program. So it writes the commit hash and the URL of the repository and the last deployed slot and so on. Then the second instruction here is our IDL buffer. So set IDL buffer of anchor. It calls our program and then it sets some data. And the last one is the set program buffer. So this one is interacting with the BPF loader program and it's setting our new program buffer. And now here I can approve this. And if you have like multiple people in your team, you can also approve this with multiple people, for example, like 2 out of 5 or whatever. So I have a 1 of 1 now. And now I can also execute this. And once I execute this, our new program will be deployed. And if I refresh this, we can see that the program is now deployed. And this time it was through squads. And this was like super easy to set up. So I think this is really cool. One last step that we need to do if we deploy our program via squads is we still need to trigger the verification. So if we go down here, we can see that there is one more step needed. Solana verify submit remote job. This, hopefully we can automate this as well later, but this is just to tell OtterSec, okay, this program is now there with a new data. So I'm just gonna copy this command here. I'm gonna paste it in here. And now I need my program ID, which is this one. And I need the squads vault. So I'm just gonna put this program ID here and the vault we get from here. So we're gonna replace this. So this will be the uploader. So basically the authority of the program. And yeah, now it will send the remote job to OtterSec. They will also build it and then compare the hashes. And then we will get our green check mark back. In the last build, this was done automatically because there isn't this step in between squads. So we can just, after the program is deployed and the PDA is uploaded, we can just call verify. But since we are now doing it through squads, we still need this step here. Maybe we can automate this in the future where we just automatically listen to these PDAs created and then trigger a job. But for now, let's quickly wait here. And once this is through, we will also have the verified checkmark again.
One eternity later.
So this was also successful. We can see the on-chain hash and the executable hash are the same. And now if we refresh in the browser, we will have our verified checkmark back. So the program source is verified. Now we also have here the program multisig in the upgrade authority. Here we have all the verified build information, so everyone can just run this command here himself locally, and they know that the program is exactly the source code that they say it was. And yeah, you also have this nice green checkmark here. One step I forgot to mention earlier maybe is that your key pair that you define in your secrets needs to be a member of your squads. Otherwise it will not be able to create this transaction. And it needs a minimum voter rights in your program. So this is basically my local MAC address, and this is also the address that I added here as a GitHub secret in this repository. So yeah, this is one thing you still need. But beside that, that's it. So now you can just run these actions whenever you want. And you can see that the longest part is actually now writing the program buffer here. So you can increase your priority fees a little bit. There's this quick node priority fee tracker. So if you're like at low or medium, then it's a little bit faster. But beside that, you can see these are now way faster. And the tests, when you run them a second time, they will also be much faster. So it's not multiple minutes. And if you have not an Anchor program, but a native program, then this will also be way faster, because Anchor is for some reason compiling multiple times. So yeah, but that is it. You have also the documentation here. You can theoretically also run this locally. You just need to copy the workflow into your repository, and then you can use act to run these locally as well. And then we'll also be outputting the IDL and the SO file here locally for you. You can also run the tests locally. And now, yeah, you can just experiment. So you can, for example, set something up which whenever you push to a development branch, it deploys your program to devnet. Or whenever you push a tag, you could automatically do a release to mainnet. Or you could set up a matrix build that builds all your programs in your repository. So there's lots of things you can do with this. And yeah, if you have a squads integration, it's also a little bit more secure, because you can like look at the transaction again and see if it's actually what you wanted. And if you want to contribute, if you think you can improve these actions, please feel free. It would be really cool to get like some new actions. The next thing we want to build, or what I would like to see, is Kodama IDL support. Then also building Pinocchio programs. That would be really cool. Maybe Steel programs would also be cool. I hope they will all work kind of out of the box, because they all use Solana Verify build, which is like already building the program in a Docker container. But yeah, try this out and give some feedback. I'm very happy for PRs if you see some improvements, how this can be made faster or better or more secure. And yeah, thank you very much, and see you next time.